Astronomers tracking 3I Atlas say it has altered its course, worrying scientists about its close proximity to Earth.
When word first spread through NASA's channels that 3I/Atlas had undergone a dramatic transformation, astronomers and space enthusiasts across the world were stunned. This object, an interstellar traveler from far beyond the bounds of the solar system, had already been a source of intrigue since its detection. Now, in a sudden and unanticipated event, it had split into two separate fragments. Instruments trained on the object confirmed the division, and with the confirmation came a flurry of excitement, confusion, and speculation. Unlike ordinary comets from within our own planetary neighborhood, whose behaviors are at least broadly predictable, an interstellar body carries with it mysteries from entirely different stellar nurseries. Its breakage represented not just a surprising astronomical development, but a window into forces that scientists had yet to fully grasp. Before we start, smash the like and subscribe buttons for more updates. The first thing that makes this event so striking is the nature of 3I/Atlas itself. As only the third known interstellar object to pass through our solar system, it has always been a rare and precious visitor. Unlike the countless comets cataloged over centuries, an interstellar object brings with it material forged in another star system. This means that when it behaves in ways we don't expect, the stakes of understanding that behavior rise exponentially. Observations of its structure, surface activity, and now fragmentation promise insights into conditions light years away, in regions of space we can otherwise only imagine through telescope lenses. So when 3I/Atlas split apart, it was not simply an astronomical curiosity. It was a revelation that demanded explanation. Scientists immediately began to consider the known mechanisms that can cause such breakups. In comets native to the solar system, fragmentation often results from heating as they approach the sun. Solar radiation drives volatile gases out of the comet's core, and this outgassing can build pressure beneath the crust until the nucleus cracks apart. But with 3I/Atlas, things do not align neatly with the patterns astronomers expect. Its distance from the sun at the time of the split was not one that typically induces catastrophic structural failure. The split seemed spontaneous, as though driven by an internal process rather than an external one. That discrepancy is what lies at the heart of the current mystery. Adding to the enigma is the fact that this object has not followed the same compositional blueprint as comets born under our sun's influence. Every spectral analysis conducted so far has hinted at unfamiliar ratios of ices, dusts, and minerals. Some of these ratios suggest conditions far colder than most regions of our own solar system. Others imply a history of irradiation under stellar light quite different from what we know here. These differences mean that theories about comet fragmentation may need to be broadened or rewritten entirely to account for interstellar matter. The moment 3I/Atlas split, it forced researchers to confront the possibility that processes common in other star systems may manifest in ways we have never before recorded. The sheer unpredictability of the event left many teams scrambling to repoint telescopes, coordinate data, and analyze the twin fragments. Each fragment carries the same genetic signature of its parent body, but subtle differences between them might reveal how stresses were distributed through its interior. For example, if one fragment is significantly smaller, yet more intact, it could suggest that internal voids collapsed unevenly. On the other hand, if both pieces show similar mass and brightness, it may mean that the body was already predisposed to split along a particular weakness, like a cosmic fault line waiting to be triggered. These observations are not just about one object. They establish precedent for what scientists might expect when encountering other interstellar wanderers in the future. The implications stretch deep into the philosophy of planetary science. For decades, comets have been seen as time capsules preserving pristine material from the early solar system. Interstellar objects like 3I/Atlas multiply that value by an order of magnitude, carrying information from completely alien origins. The splitting of such a body gives astronomers an unprecedented chance to compare its interior and exterior simultaneously. If the surfaces of the fragments are freshly exposed, they can reveal volatile compounds and mineral structures that may have been shielded for eons. Observing how these materials sublimate or react under solar radiation allows researchers to glimpse the chemistry of a distant star system in real time. There is also a powerful narrative about fragility in this event. Space often feels like an environment of permanence, with asteroids and comets enduring for billions of years, traveling vast distances untouched. But 3I/Atlas demonstrates that even interstellar travelers, hardened by unimaginable journeys, journeys can be vulnerable. The stresses that tore it apart may have accumulated long before it ever entered our solar system. Perhaps it endured gravitational encounters with giant planets in its home system, or collisions with other icy bodies during its ejection. The splitting we witnessed may simply be the delayed outcome of those ancient traumas. In this sense, the fragmentation is not an accident, but the final chapter in a much longer story of endurance and strain. The difficulty for scientists lies in the lack of precedent. With only a handful of interstellar objects ever observed, each one challenges existing models. Where solar system comets provide patterns and rules, these visitors force exceptions. They underline the incompleteness of our knowledge and remind us that the cosmos is infinitely varied. 3I/Atlas splitting apart is not something that can be explained away as a routine occurrence. It has to be wrestled with, studied, and reconsidered until a framework emerges. This challenge is invigorating to the scientific community because every unanswered question is also an invitation to discovery. Astronomers have also been quick to highlight how fragile our grasp on such opportunities can be. Observing 3I/Atlas was already a fleeting endeavor, given the speed at which interstellar objects sweep through our sky. Now, with two fragments moving apart, the observational challenge doubles. Coordinating global telescope networks becomes crucial, ensuring that every moment of visibility is maximized. Each fragment offers only a narrow window of time before it drifts too far to study in detail. The urgency fuels a sense of collaboration and determination across nations and institutions, all united by the chance to witness a phenomenon with potentially transformative consequences. The question of why it split remains unanswered, but that uncertainty is itself valuable. It signals that forces at work in interstellar comets might differ in scale or type from those in solar system comets. Some astronomers suspect thermal fracturing combined with exotic ices unfamiliar to us may be the culprit. Others wonder whether subtle tidal forces from planetary encounters in our own system nudged it past a threshold. Still others speculate that interstellar radiation, accumulated over millions of years of travel, weakened its bonds until even mild stresses became catastrophic. Each theory, though unproven, expands the scope of how we conceive cometary evolution beyond the solar neighborhood. The public fascination with this event is no less important. Every time an interstellar object is detected, it captures the imagination of people far beyond astronomy circle. 3I/Atlas splitting into two only amplifies that fascination because it mirrors narratives humans instinctively respond to. Something ancient and foreign breaking open to reveal its secrets. It becomes a cosmic drama, unfolding light years from its origins yet visible in our skies. This shared wonder reinforces the role of space science not only as a pursuit of knowledge, but as a cultural and emotional connection to the universe. It is worth considering the scale of what might be learned from this single event. If scientists can determine the composition of freshly exposed interiors, it could refine models of planet formation around other stars. It might show which elements and compounds are abundant or rare in those environments. This, in turn, influences theories of habitability, because the chemical inventory of a star system shapes the planets and potential life that emerge there. By understanding the split of 3I/Atlas, humanity inches closer to comprehending the diversity of worlds beyond our own. The event also provides a practical rehearsal for future encounters. Interstellar objects are expected to be discovered more frequently as telescope surveys improve. Each one will have its own trajectory, speed, and quirk. Learning how to rapidly mobilize resources when an object behaves unpredictably, such as by splitting, is invaluable training. The scientific community is effectively writing the playbook in real time, guided by the lessons that 3I/Atlas is offering. The grandeur of this moment lies not only in the immediate mystery, but in the implications that ripple outward. A split comet may seem like a small event on a cosmic scale, but its significance magnifies when framed as a test of our understanding of matter, motion, and the forces that shape planetary systems. It challenges us to see beyond the assumptions drawn from our own solar neighborhood. It presses us to expand models, embrace anomalies, and recognize that the universe is vaster and stranger than we often allow. At the same time, there is a humility in the acknowledgement that we may not yet have the tools to fully explain what happened. The split of 3I/Atlas stands as a reminder of limits, both technological and conceptual. Telescopes and spectrographs can capture data, But interpreting that data requires frameworks that might not yet exist. This does not diminish the event's importance, it heightens it, because every unanswered riddle spurs the development of new methods, new collaborations, and new ideas. As scientists continue to monitor the fragments, the world waits for clarity. But even without complete explanation, the story of 3I/Atlas has already become part of the broader tapestry of interstellar exploration. It underscores the serendipity of discovery, the rarity of such encounters, and the inexhaustible capacity of the universe to surprise us. The two fragments moving silently through space are more than debris. They are messengers from another sun, carrying information that no probe or mission has yet been able to retrieve directly. Their sudden division is not an end but an opening, inviting deeper inquiry into what lies beyond. This event reminds us that cosmic phenomena do not adhere to the boundaries of human expectation. Just when it seems as though a new object might follow predictable paths, it demonstrates independence, asserting that the universe cannot be tamed by formulas alone. The split of 3I/Atlas into two fragments is both a puzzle and a gift, urging us to continue reaching, studying, and imagining. It captures the essence of science, the confrontation with the unknown, and the exhilaration that comes from knowing there is always more to learn. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I/Atlas splitting? Natural cosmic event or something unusual? We want to hear from you. Thank you for watching and see you next time.